Hello everyone, welcome back to another video. In this video, we'll be talking about an API that we came across that was leaking all its client PII information. However, that API was responding all the data in AES encryption. I am very sure that we would have come across, as a fellow pen tester, we had come across this area where all the data that is being pointed out, or all the data that we want to modify, either it is AES encrypted or some sort of encryption is in use. So the focus of this video mainly would be how we were able to figure out the decryption algorithm and method the client has been using, and how you could do the same as well. What we found out was the API call that is returning an AES encrypted ciphertext. The text contained all the data of the client, including all the PII data of all of the client, and the API call was unauthenticated as well. And this was a way of developer to avoid any data leaks if the API has been leaked somehow. However, when analyzing the network traffic of live application, we identify that there was a call being made on fetch_key. We'll see in other slide how this came into the picture and how it could be used and what exactly it is being used for. We also noticed that desktop application is doing the same thing, calling the API key and storing it, the calling the fetch key and storing it for decryption. What we found out was the API call that is returning an AES encrypted ciphertext. The text contained all the data of the client, including all the PII data of all of the client, and the API call was unauthenticated as well. And this was a way of developer to avoid any data leaks if the API has been leaked somehow. However, when analyzing the network traffic of live application, we identify that there was a call being made on fetch_key. We'll see in other slide how this came into the picture and how it could be used and what exactly it is being used for. We also noticed that desktop application is doing the same thing, calling the API key and storing it, calling the fetch key and storing it for decryption. And there was no server-side control or prevention for us from that would restrict us to either decrypt it or view the function that was decrypting it. All right, let's talk about how this encryption flow was intended to be work originally. So the browser or desktop application was making a call to fetch the key, and the key that API call was sending the encrypted key block back to the server. However, this was in base64 encoding, just in base64 encoding. When we decrypted, it would just result as into binary. So basically, we can't directly see the access key, but that key has been stored on the client side browser and in one of the variable. And whenever any response that is coming from the server has been used, this particular function decrypt has been used to decode those response and present the decoded content on the UI side. We also were able to find out that the VIV that has been used was the first 16 bytes of all the encoded responses. So this was a clever way for developer to avoid hard coding any secret key on the client side and still use the decode functions on the client side. So there are plenty of ways to not show the exact function that is doing so. So that would avoid any situation that could be misused. And this is also an unique to the situation. The API call for fetch key you won't come across such API calls, but it is very wise to just go through the encryption method. If you came across any response that is AES encoded and the content of that response has been displayed on the UI side, the decoded content, of course, it is very wise to go through the JavaScript and trace back what exactly is happening, or what all functions exactly is being used to decrypt or to just present that data. You might come across some interesting ways to use it. So let's talk about how we were able to, what we did with those functions. So the knowing the function to decrypt the AES algorithm in itself does not have any vulnerability, or in itself is not an vulnerability. However, it would be a different case if we were able to get the secret key out of the function. Then it would be a vulnerability, of course. But if that is not the case, then using that function to either encrypt or decrypt the malicious content or the payload that we want, and just checking how the server respond to those content would be a great choice, because many time encrypted response or encrypted content that is sending or receiving from the server does not been properly analyzed or properly sanitized for any sort of malfunctions. So that opens up a lot of areas where using just the decryption function, we could target and get the intended or unintended behavior of the web application. And that is what exactly what we did. Once we figure out the function, how the exact working of the function and decryption, we were able to create or reverse engineer it and create a script for ourselves to be used to decrypt the content of it. We did in the PowerShell, and you could do the same thing just by going through the content and either use ChatGPT. It would save a lot of time directly asking it to replicate the function in different languages. You can see we not only were able to use the same method to decrypt the AES encryption, but also encrypted. So basically now we have a script, but encrypt and decrypt the AES encryption for us that has been sent or received from the server. And that is how where we were able to decrypt the content of the encrypted response. You can see this is how the response was initially looking. Once we decoded, we were able to get the content of the API information of all the clients that have been presented. So this was an vulnerability that was reported based on the PI information it was leaking. But how we were able to misuse the encryption is very interesting. And you could do the same when the same situation or a similar situation arises. Let's talk about the mitigation for this. So instead of sending a decryption key or unwrapping logic to the client, it's always a bad idea. Instead of doing that, decrypt in the server side and return the minimal field would be the best option. Or a proper sanitization check or access control over the APIs would be a best option as well, because instead of trusting the AES encryption direct completely, it would be a best approach if the sanitization check or access control has been placed on all the API. So in terms of in a situation when the decryption function or any such things, even if that has happened or attacker got the access of those functions, there is no way it could be misused due to the access control properly placed in it. And yes, revoking the key, regenerating it for the different line would be also an possible solution, or using request signing for the function so that the function is not being misused. So yes, that was all for the this video. Thanks for joining in, and have a nice day, guys.